What is up, Geo Metro Ninjas? I am making this one because conditional probability had a little bit of some quirks to it, so I wanted to make an individual video just doing some conditional probability. I'm going to show you the way to use the formula, and then I'll show you guys a way to use our reduced sample sizes. Okay, so conditional probability is just simply a probability where a certain prerequisite condition has already been met. So some examples would be, what is the probability of selecting a queen given an ace has already been drawn and not replaced? Or what is the probability that a student is enrolled in biology given that they are enrolled in geometry? Essentially, what happens is conditional probability simply reduces our sample size. Okay? So when you see conditional probability, you'll see it expressed as this. And I apologize, I left my good stylus at school, I reckon. So you may see a little bit less than neat handwriting, and it happens. So probability of A, and if you guys remember, given B. So that guy right there, that little bar, that represents given. Oh, this stylus is awful. I'm sorry, guys. Okay, that represents given. And the formula for conditional probability, okay, is, remember, it's probability of A given B. So whatever the event is, okay, is equal to the probability of A and B divided by the probability of just B. Okay? And then we can reduce that a little bit more because we already know the shorthand for and. So the probability of A and then intersection B. So A and B over the probability of B. Okay, so remember, if we think back to simple probability or independent and dependent, okay, the probability of A intersection B, so where the two come together, is just the probability of A times the probability of B. Okay, so let me scoot the screen over so you can see it. My apologies there. Okay, so the probability of A times the probability of B. So whatever A is, you just multiply it by B. So let's do a couple examples. You're playing a game of cards where the winner is determined by drawing two cards of the same suit. What is the probability of drawing clubs on the second draw if the first draw is a club? Okay, so we want probability of club given, we've already pulled club. Let's go back to teal. So we want probability of club given club. Okay, so if we write this out so we can kind of see what's happening, so the probability of a second club, okay, and a first club. Probability of a second club and a first club, and then of course we're going to divide that by the probability of that first club, max. And if you guys hear some craziness, there is machine work going on outside, and it's kind of freaking my dogs out. So Max may or may not bark in between this. And I apologize because he is a little shrill. All right, so probability of a first club. Okay, so if you think back to independent and dependent events, if we're already going to assume that we have pulled what we wanted. So we're going to assume we pulled a club on the first draw. So now there's only 12 clubs left in our deck, and there's only 51 cards left in our deck. Okay, and then our first draw there were 13 clubs and 52 total cards, and that of course is over the probability of 13 out of 52, because that was the probability of B happening, our first draw. So we get 4 out of 17 when we pop that all into our calculator. Or, again, we can express probability as a percentage. We would say 23.5%. Okay. So we took the probability of our second club and the probability of our first club. So if you remember, this is A, this is B, okay, A, B, and then you can see A, B, and then probability of B goes in the bottom as well. So you guys can kind of see how those probabilities kind of roll along through. It's a little bit tricky, but the more you guys practice it, the better we're going to be at it. Okay, our next one says a bag contains 6 marbles, and are 6 blue and 2 brown. 1 marble is randomly drawn and discarded, meaning it's not getting put back in. Then a second marble is drawn. Find the probability that the second marble is brown given the first marble was blue. Okay, so we've got probability brown for our second marble given the first was blue. Okay. So again, probability of a brown marble. So brown and blue all divided by the probability of blue. Put that little guy in there. So we've got, so if we're going to pull a brown marble, okay, how many total marbles did we start with? So we got 6. So there were 8 total to start. Okay. This time we're going to assume we pulled a blue marble. And we put it off to the side. So that means there's only 7 marbles left. And of those 7 marbles, how many are brown? That would be 2. And of course, we're going times the probability that we pulled a blue in the first place. So 6 out of 8. Pretty good chance that we pulled a blue. And that, of course, is divided by 6 out of 8. Sorry, guys, I ran out of space down there. The stylus is kicking my butt. So when we do all that, we end up with a 2 out of 7 chance, or 28.6%. So we said, all right, we did our blue drawing. We got a blue marble. So when we go back for that brown marble, there's only 2 out of 7 chance. Mrs. Jonas's homeroom of 70 students, 70% have brown hair, 25% have brown eyes, 5% have both brown and brown. Okay, so they have 25.5 or 5% have both. A student is excused early to go to the doctor's appointment. If that student has brown hair, what is the probability that the student also has brown eyes? Okay, so when we look at Miss Jonas's homeroom, okay, so again, they want brown hair. Brown hair given they've got, backtrack, read the question, Coach O. If the student has brown hair, what is the probability that they have brown eyes? So brown eyes goes first because they're saying that our given is brown hair. Okay? So it's the probability that both are true. So eyes and hair, intersection hair, okay, over the probability of just the brown hair. Spelling hair right? It looks funny. Just a funny looking word, huh? So what is the probability of both? Well, they gave it to us in our example. They gave us 5% have both brown hair and brown eyes. So they've already done the probability for us. So that's going to make our lives a little easier. Can't write in highlighter dummy. So we're going to take that percentage and change it to a decimal because we can't really work with percentages. Okay? And then, of course, the next one says, what is the, so we only want the probability of brown hair. Well, 70% have brown hair, so that's going to go in the bottom. And again, we're going to change it to a decimal so we can work with the numbers. Okay, pop that into the old calculadora, and we hit math frac. We get about 1 out of 14, or a 7.1% chance. Right? This concludes page 1 of our conditional probability